I'll be the one starting off our group's presentation, and the topic that we have selected is the SSL protocol. And without further ado, we shall now start. Have you ever noticed that some URLs start with HTTP while others start with HTTPS? Maybe you noticed that extra S when you were browsing websites that require giving over sensitive information, like when you were paying bills online. But where did that S come from? And what does that mean? To put it simply, the extra S means your connection to that website is secure and encrypted. Any data you enter is safely shared with that website. The technology that powers that little s is called SSL, which stands for Secure Sockets Layer. As a consumer, you always want to see HTTPS. When visiting any site you trust with your essential information. As a small marketer, you'll want to make sure you have an SSL or two for your audience. What is an SSL certificate? SSL certificates are small data files that cryptographically establish an encrypted link between a web server and a browser. This link ensures that all data passed between the web server and browser remain private. When you land on a page with a form to fill in and submit, the information you enter can be intercepted by a hacker on an unsecure website. This information could be anything from details on a bank transaction to an email entered to register for an offer. In hacker lingo, this interception is often referred to as a man-in-the-middle attack. Wondering how attacks happen? Here's one of the most common ways. A hacker places a small, undetected listening program on the server hosting the website. That program waits in the background until a visitor starts typing information on the website itself, and it will activate to start capturing the information and then send it back to the hacker. But when you visit a website that's encrypted with SSL, your browser will form a connection with the web server, look at the SSL certificate, then bind your browser and the server. This binding connection is secure to ensure no one besides you and the website can see or access what you type. This connection happens instantly, and in fact some suggest it's faster than connecting to a unsecure website. You simply have to visit a website with SSL and voila, your connection will automatically be secured. An SSL is security technology. It's a protocol for servers and web browsers to make sure that the data passed between the two are private. This is done using an encrypted link that connects the server and browsers. Companies that request personal information from a user, such as an email address or payment information, should have SSL certificates on their website. Having one means that the details you are collecting are private and ensures that the customers that when they see that padlock and HTTPS their privacy is safe.
We're gonna discuss SSL. Secure Site Layer, or SSL, was the original name of the protocol when it was developed in the mid-1990s by Netscape, the company that made the most popular web browser at the time. SSL 1.0 was never released to the public, and SSL 2.0 had serious flaws. SSL 3.0, released in 1996, was completely revamped and set the stage for what followed. In SSL, encryption is necessary in order to communicate securely over the internet. If your data isn't encrypted, anyone can examine your packets and read confidential information. The safest method of encryption is called asymmetrical cryptography. This requires two cryptographic keys, pieces of information, usually very large numbers, to work properly, one public and one private. The mathematics here are complex, but in essence, you can use the public key to encrypt the data, but need the private key to decrypt it. Two keys are related to each other by some complex mathematical formula that is difficult to reverse engineer by brute force. Think of the public key as a information about the location of a locked mailbox with a slot on the front, and the private key as the key that unlocks the mailbox. Anyone who knows where the mailbox is can put a message in it, but for anyone else to read it, they need the private key. Because asymmetrical cryptography involves these difficult mathematical problems, it takes a lot of computing resources, so much so that if you use it to encrypt all the information in a communication session, your computer and connection would grind to a halt. TLS gets around this problem by only using asymmetrical cryptography at the very beginning of a communication session to encrypt the conversation. The server and client to have to agree on a single session key that they both use to encrypt their packets from the point forward. Encryption using a shared key is called asymmetrical cryptography, and it's much less computationally intensive than asymmetric cryptography because that session key was established using asymmetrical cryptography. The communication session as a whole is much more secure than it otherwise would be. The process by which the session key is agreed upon is called a handshake. Since it's the moment when the two communicating computers introduce themselves to each other, and it's the heart of the TLS protocol. So let's moving on to the SSL handshake process. The handshake process is quite complex, and there are a number of variations allowed by this protocol. The following steps provide a broad outline that should give you a sense of how it works. Number 1, the client contacts the server and requests a secure connection. The server replies with the list of cybersuits, algorithmic toolkits of creating encrypted connections, and that it knows how to use. The client compares this against its own list of supported cybersuits, select one, and let the server know that they'll both be using it. Number 2, the server then provides its digital certificate, an electronic document issued by a third-party authority confirming the server's identity. We'll discuss digital certificates in more detail in a moment, but for now, most important thing you need to know about them is that they contain the server's public cryptographic key. Once the client receives the certificate, it confirms the certificate's authenticity. Number three, using the server's public key, the client and server establish session key that both will use the rest of the session to encrypt communication. There are several techniques for doing this. The client may use the public key to encrypt a random number, then send to the server to decrypt, and both parties then use that number to establish the session key. Or alternately, the two parties may use what's called a Diffie-Hellman key exchange to establish the session key. So that is the handshake process.
What is SSL and how does it work? A secure socket layer or SSL is a computer networking protocol for securing connections between network, application and clients and servers over a secure network such as the internet. SSL establish a secure link between a web server and a browser to transmit data. To encrypt data, SSL uses two different keys, a public key and a private key. The public key is put into a file that contains your details, is called a certificate signing request or CSR. Next is the certification authority validates your details and gives you an SSL certificate. This allows you to use SSL. Your web server then matches your SSL certificate to your private key. This allows your web server to create an encrypted link between the website and your web browser. SSL is especially important for websites where users enter confidential informations or sensitive informations such as address, identity, credit card numbers, whatever data you have. URLs that use SSL connections begin with HTTPS rather than HTTP due to numerous protocol and implementation flaws and vulnerabilities. SSL was deprecated for use on the Internet by the Internet Engineering Task Force or IETF in 2015 and has been replaced by the Transport Layer Security or TLS protocol, while TLS and SSL are not interoperable. TLS is backwards compatible with SSL 3.0. How does it differ from TLS? Both TLS and SSL are protocols that, that help you securely authenticate and transport data on the internet. TLS is actually just more recent version of SSL. It fixed some security vulnerabilities in the earlier SSL protocols. Not only is TLS more secure and performant, most modern web browser and no longer support SSL 2.0 and SSL 3.0. For example, Google Chrome stopped supporting SSL 3.0 all the way back in 2014, and most major browsers are planning to stop supporting TLS 1.0 and TLS 1.1 in 2020. So why is SSL important? The, the primary reason why SSL is to keep sensitive informations or confidential informations sent across the internet encrypted so that the only intended recipient can access it. So only the receiver can access the information you sent it. Then this is important because the information you sent on the internet is passed from computer to computer to get the destination server. Any computer in between you and the server can see your credit cards, numbers, usernames, passwords, and other information or other sensitive or confidential informations if it's not encrypted with an SSL.
According to Colin Walls in Embedded Software 2nd edition 2012, Secure Socket Layer SSL and Transport Layers Security TLS provide a secure protocol by which two network peers may perform encrypted communications. SSL is most commonly used for sending private data from a web browser to a web server. This private data may include credit card numbers or other personal information. Virtually everyone who has browsed the web has at some point used SSL but may not have realized it. When browsing the internet, if the browser states that it is entering a secure site, then SSL is being used to authenticate the web server and to encrypt the data exchange. Netscape created SSL 1.0 in 1994. However, version 1.0 was never shipped. The first working version of SSL was 2.0. This was packaged in Netscape Navigator in late 1994. Netscape continued to work on SSL with the help of outside engineers. A year later, SSL 3.0 was released in 1996. The Internet Engineering Task Force IATF took over responsibility for the protocol from Netscape. The IATF chose to rename the protocol to TLS Transport Layer Security, perhaps thinking a name not linked to Netscape would be more acceptable. This newly named protocol can be found in RFC 2246. Since that time, only one version of TLS was released in early 1999. Current widely used standards are SSL 2.0, SSL 3.0, and TLS 1.0. The name SSL is still more commonly used to refer to all versions of the protocol as a result within this article. SSL will be used to mean either SSL or TLS. The Web or HTTP Hypertext Transfer Protocol is the most common but not the only used for SSL. Other protocols such as FTP, SMTP, and POP3 email can be modified to utilize SSL, or SSL can be used with basic TCP or UDP. Communications use the data to be sent has been created. SSL encapsulate the data in much the same way TCP would. There is one difference: SSL modifies the data by encrypting it. Many SSL implementations are based upon OpenSSL. OpenSSL is a free, open-source SSL solution. OpenSSL was not developed with the embedded industry in mind, so care is needed for it to be used efficiently in this context. SSL and TLS. Secure Socket Layer SSL was designed to protect HTTP, Hypertext Transfer Protocol data. HTTPs use TCP port 443. TLS Transport Layer Security is the latest version of SSL, equivalent to SSL version 3.1. The current version of TLS is 1.2 described in RFC 5246. Though initially web-focused, SSL or TLS may be used to encrypt many types of data and can be used to tunnel other IP protocols to form VPN connections. SSL VPNs can be simpler than their IPsec equivalents. IPsec makes fundamental changes to IP networking. So installation of IPsec software changes the operating system which requires super user privilege. SSL client software does not require altering the operating system. Also, IPsec is difficult to firewall. SSL is much simpler. According to Eric Conrad and colleagues in CISSP Study Guide 3rd edition 2016. Secure Socket Layer. Secure Socket Layer SSL provide authentication and encryption services or can be used as a VPN. From a sniffing perspective, SSL can be vulnerable to a man-in-the-middle attack. An attacker can set up a transparent proxy between you and the web server. This transparent proxy can be configured to decrypt the SSL connection, sniff it, and re-encrypt it. When this happens, the user will be prompted with a dialog box indicating that the SSL certificate was not issued by a trusted authority. The problem is most users ignore the warnings and proceed anyway. According in Hack the Stack 2006 study, SSL requirements. Running a report server that is SSL enabled in SharePoint integrated mode requires that the SharePoint web application also be configured to use SSL. SSL on SharePoint is necessary because all report server requests originating from SharePoint are sent through a reporting service, uniform resources locator, URL, proxy endpoint within SharePoint, which obtains encryption requirements from the report server. By configuring the SharePoint web application to use SSL, the endpoint uses SSL. Install and configure the server certificate on both servers using IIS Manager, assign port and select the required Secure Channel SSL checkbox on the website accessing the SharePoint web application and the report server. Assign a unique port if the default port 443 is used elsewhere on the server.
So this is why you need an SSL certificate. First is SSL certificate are required for a website in order to protect user data, validate website ownership, prevent attackers from creating a false version of the site, and transmit trust to user. Second is it is critical to keep data secret in website as user to sign in. Submit personal information such as credit card number or read confidential information such as health benefits or financial information. SSL certificates helps to keep online interactions private by assuring consumer that the website they are visiting is legitimate and safe to exchange personal information with. The third is the fact that an SSL certificate is necessary for an HTTPS web address is more significant to enterprises. HTTPS is the secure version of HTTP, which means that HTTPS website use SSL to encrypt their traffics. Most browser label HTTP sites, those without SSL certificates, as not secure, implying to consumer that the site isn't trustworthy. This encourage business that haven't switched to HTTPS to do so. Next is, so this is the advantage of SSL. First is the SSL protects sensitive information. Second is SSL affirms your business identity and improve customer trust. Third is a better search engine ranking. And last is SSL help you satisfy PCI or DSS requirements. So the disadvantage of SSL. First is the performance. When the SSL certificate is used on the site, the speed of transaction will get drastically reduced. The second is cost. Purchasing and setting up a SSL certificate can be quite expensive. And third is expiry. Fourth is the data integrity. Fifth is the caching. Sixth is protocol complication. And last is the application support. So next is what happens if you don't invest in an SSL. According to our research, if you don't have an SSL certificate, your website may still function as always, but it will be vulnerable to hackers, and Google will warn visitors that your website is not secure. And build trust by adding an SSL. With an SSL certificate, your customer will see a green padlock icon or green address bar that indicates well-trusted encryption. This gives visitors and potential customers peace of mind when they browsing your website. Last of this video is SSL necessary for email? It's important to use SSL or TLS with your email setup because unsecure email is a common attack vector for the bad guys. Anyone who intercept encrypted emails is left with garbage text that they can do anything with, because only the email server and client have the key to decode the message.